Forces in equilibrium, lecture number 7, frictional force, part 2. If we have already done part 1 and part 2 when we have vertical force, right? Case 1 and case number 2. Now let's just work upon case number 3. So, case 3 is object in limiting equilibrium. Limiting equilibrium. So when the object is in limiting equilibrium, so what do we need to do? In limiting equilibrium, the object can always be in two possible positions. Number A, about to move upwards. Number A, about to move upwards. Number 2, it will always be about to move downwards. Now, but the frictional force will act downward when it's about to move upward. So what does this mean? Let's say that this is your normal, let's say, force being applied on the ring, right? So if the force is being applied and there is theta given, so what will be the weight? Your weight will be mg, right? But at this point, this should be F sine theta and this should be F cos theta. The normal reaction will be on the left hand side, which will be reaction should be F sine theta. Make sure that obviously it is in the balancing out force. So frictional force at this point of time will act downwards. Since it is of what moving upwards, it is about to move upwards. So frictional force will be downward. So upward force will be F cos theta and downward force will be weight plus frictional force. Weight plus frictional force. So what we need to do is limiting equilibrium. So F cos theta is equal to weight plus frictional force. So F cos theta is equal to mg plus mu r. So this should be F cos theta is equal to mg plus mu f sine theta. So this becomes what? About to move. When the question clearly says about to move upward. So when it says about to move upward, at this particular time, it will be at what? Limiting equilibrium. So your upward force will be equal to what? Your downward force. Now, if in the same situation, if we just work upon what? Work upon about to move downwards. So let's just say it says about to move downwards. So part B, about to move downwards. Move downwards. Then the frictional force will act upwards. Then frictional force will act upward. Remember this. So when the question is very clear about to move downwards, we will look upon the forces which will move upward and downward. So if the question says downward force is mg and upward force is f cos theta, and the question says the force is going downwards, that means the limiting equilibrium is going downwards, and frictional force will be upward. So when the frictional force is upward, so what we can do is your upward force will be upward will be F cos theta plus frictional force. And downward force will be mg, right? Downward force will be mg, right? So this will become what? Your downward force. Considering your downward force will only have what? Weight. Now, considering this should be F cos theta plus frictional force should be equal to what? Your weight, which is equal to what? Mg. So F cos theta plus mu r is equal to mg, and F cos theta plus mu, your r is F sin theta, is equal to mg. So this will be your, when we have limiting equilibrium, friction force moving towards downwards. Now let's just work upon frictional force on an inclined plane. Now what does inclined plane mean? Now this is your horizontal, right? There's an inclined plane that is there, right? The inclined plane has the object in it. Let's say this is your object. Now, considering that this is your object, your theta is already given. The force that is being applied on the object is making sure that it is upward. So, question states that if we just work upon that the force is 0, before moving forward, we should be knowing that the object has its own weight, which is mg. The object has its own weight, that is mg. Let's just write it down here. Weight is equal to mg. So obviously, if there is a plane and there is a block moving downwards, so there would be a reaction, normal reaction as well. So if we just have the vertical force downwards and on the left, so this will be downwards and on the left to the plane. So this should be mg cos theta and this should be mg sin theta. Why? Because if this is the state, we can directly say this angle becomes 90°. This angle will be 90 minus theta. So automatically this angle becomes theta as well. So if this angle is theta, so we write down this thing as theta. So this becomes mg sin theta, this becomes mg cos theta. So your normal reaction will be perpendicular to the plane. And the reaction will be mg cos theta, because your downward force is mg cos theta. So your upward, to balance out the force using the normal reaction, will be mg cos theta. Now, when we know one thing, that let's say that there is F1 being applied, that means force 1 working on case 1, which means force 1 is equal to 0 Newton. So if there is no force, and let's say surface is smooth, there is no friction on this, so surface is smooth. So what do we apply? We apply normal FR, force reaction, which will be downward force, that means sliding force. Let's just name that sliding force as F3 will be your sliding force. So your FR is equal to what? F3. Because F3 minus F1, F1 is equal to 0. So it becomes FR is equal to what? F3, because F3 becomes your sliding force. So sliding force is automatically generated through Fmg sine theta. Mg sine theta. So this becomes your sliding force acting on the left hand side towards the plane. So that means mg sine theta will be applied, which will be a sliding force. Where there's no force, that is obviously making sure that the object is going upwards. So we have FR is equal to F3, or let's just let's just name this as the sliding force. So let's name this as Fs rather than F3. So let's just say Fs. So sliding force it is. So sliding force minus your force 1. Sliding force minus your force 1. So let's just say this is your sliding force. So Fs, so Fr is equal to Fs. So noting the fact that Fr is equal to Fs. So this should be Ma is equal to Mg sine theta. So M and M is cancelled. So A becomes G sine theta. That means the acceleration that is being applied is A. G is equal to what? G sine theta. If we just say that the surface was not smooth, if we just say that surface was not smooth, so that means case number 2, surface is not smooth. So in this regard, same thing, that F1 is 0 Newton, but now since surface is not smooth, surface is rough. So, and the object moving down the plane, So now that one thing that we know is that if the object is moving down the plane, if object is moving down the plane and F1 is 0, but still there is one particular thing, notion in this, that is your frictional force, because it is rough. So that means your force 1 plus your frictional force will be applied upward, whereas downward it will be mg sine theta. That is your force, sliding force. The sliding force is what? Mg sine theta, which will give you your resultant force. And your resultant force is what? Ma. So considering the same options, what we need to understand is that your part here will be that means FR is equal to what? Sliding force minus force 1. So FR is equal to MA is equal to FMG sine theta minus. Now F1 involves what? F1 involves the frictional force as well. F1 also involves the frictional force as well. So that means F1 is 0. F1 is 0. But your frictional force will be what? Mu R. So minus mu R. So that means MA becomes mg, this is plus, minus mu R. So your reaction was already well known. That is mg minus mu mg cos theta. This was mg cos theta. So we consider that mg, m is common. So m is common between them. So we are left with what? G minus mu G cos theta, right? So M and M is cancelled. So what you are left with? A G sine theta. What do we have is G considering the same act. We are left with A is equal to G sine theta minus mu G cos theta. Now this was what? Mg sine theta. Mg sine theta. Right? Because the force was, this was your force. That was mg sine theta. So that is the reason when the force is there, this is your sliding force, this is your upward force. So mg sine theta. So mg sine theta has 0 plus frictional force. So mg sine theta will be minus what? Frictional force. Your mu r, your r becomes mg cos theta. So mg cos theta, knowing that m is common between them. So what you are left with? A G sine theta minus mu cos theta. Now let's just work upon case 3. Right? Let's say F1 is still 0 Newton. Right? But now the question is that object in equilibrium. Object in equilibrium. And automatically, if the object in equilibrium, because of the sliding force, there should be one thing, the rough surface is also there. So if the rough surface is there, that means friction force is automatically applied. So if we just understand the concept that in this regard, the question is very clear that this is an equilibrium state. That means this is being not moving downwards, right? And this is 0, but this force is 0. If this is not moving downward, that means mg sine theta is basically what? Is in equilibrium state, right? Frictional force x what? Up the plane, right? If frictional force x up the plane, that means your sliding force is less than the frictional force. Sliding force is less than the frictional force. So what we can have is your sliding force is mg sine theta and your frictional force is mu r. That means frictional force will be mu mg cos theta. right? So if we just work upon this, the same thing here, that the question is clear, indicating that FF is friction force acts upward. When the frictional force acts upward, object is equilibrium and the object is in equilibrium, So that means your sliding force is less than the frictional force. The sliding force is mg sine theta is less than the mg sine theta. This is your sliding force, right? Mg sine theta, and the frictional force will be mu r. So minus less than what? Mu r. So this should be mg sine theta is less than mu and r is mg cos theta. Your reaction is mg cos theta. So considering this, we know that mg is in both the forms, so mg is cancelled out. So what are you left with? Sine theta less than mu cos theta. So can we just say sine theta when applied less than cos theta? So this should be tan theta less than equal to mu, or we can also write this thing down as mu is greater than tan theta. So that means trigonometric identity is applied, that sine theta upon cos theta becomes tan theta. Tan theta is less than mu, or mu is greater than tan theta. So this is the application of the case 3 when still the force being applied upward is 0. But because of the particular rough surface, the object is in equilibrium. That means the sliding force is automatically less than the frictional force. And the sliding force is mg sine theta. And your frictional force is what? Obviously, mu r. And your r is what? Mg cos theta. So we end up getting what? Tan theta is less than mu. So mu becomes what? Greater than tan theta.